Well, hello there again. This is week 2 of term 2 and our next lesson, which is going to be on empirical formula, which follows on from percentage composition. When chemists analyse a new compound to work out its structure, they begin by finding out what elements it contains and in what ratios. So usually experimentally, they can work out the percentage composition of the elements, which is what we did last week. Then they work out the empirical formula, and from the empirical formula they can then work out the molecular formula and the structural formula of the compound, particularly when we're talking about organic chemicals. So the first question is, or the first thing I'd like to tell you, is that there are different types of formulae. The first and the simplest type of formula is the empirical formula. Then we could have the molecular formula. Then there are structural formulas, and we could have a structural formula, and there are two types of structural formulae. There is what's often called the composite and also the graphic. And the graphic, as it says, has to do with pictures. So we might come up with an empirical formula, for example, CH2. What is the empirical formula? The empirical formula is the lowest possible ratio of the elements in a particular molecule. So this particular molecule that has a ratio of 2 hydrogens to 1 carbon, it could have a molecular formula of C3H6. Or it could be C4H8. Or it could be C5H10. As you can see, this is 3 times bigger. This one is 4 times bigger. Or this is 5 times bigger. Now, this particular formula with a molecular formula of C3H6, it could have a structural formula of CH3, CH2, which would mean that it could have a structure like that, putting in all the hydrogens. So both of these structural formulae show us what the structure of the molecule is like. This one in a composite form and this one in a graphic or a pictorial form. This one here could have a structural formula of CH3, CH2, CH and CH2. Notice we've got 1, 2, 3, 4 hydrogens, and we've got 8, 3, 5, 6, 8 hydrogens. So this could have a graphical formula like this, where we've got, and I won't draw all the hydrogens in, a structure like that. It could be that we have this type of structure, C3, CH, CH, CH3, still 4 carbons and 8 hydrogens. So the structural formula gives us a little bit more information. And of course, the bigger the molecule, the more complex it becomes, the greater the number of variations that we can have. So the different types of formula. We're going to start with the empirical formula, and from the empirical formula we're going to work out the molecular formula, and then later on we can try and deduce the structural formula, because that will let us know how the chemical reacts. So, how do we work out the empirical formula? Remember, the empirical formula is the lowest whole number ratio of elements in a compound. So, let's say that we were told that a compound was 80% by mass carbon and 20% by mass hydrogen. Let's have a look to see how we could work out the empirical formula. The first step is to take the percentage and to divide it by the atomic mass. So generally we work in columns, we write down the percentage and we divide by the atomic mass. And from our periodic table we can find that the atomic mass of carbon is 12 and the atomic mass of hydrogen is 1. We then calculate the product. So 80 over 12 is 6.667, and 20 over 1 is must be about 20. What we do then is we divide by the smallest product. So the smallest product is obviously the 6.66, and we divide that by 6.667 as well, and we work out the product of that. So that ratio is 1 and this ratio is 3. So this means that for every 1 carbon we have 3 hydrogens, and so the empirical formula will be CH3. Excuse me. Many people, when they work out the empirical formula, simply leave it at the ratio and they don't go to the final step of actually writing down the empirical formula, which has the elements and the numbers in there. You must finish off with the empirical formula at the end. So this means that the molecule simplest ratio is for every 1 carbon there are 3 hydrogens. Now this is not the final molecule, because there is no way that you can have 1 carbon with only 3 hydrogens. There's got to be 4 bonds going to a carbon. We'll find that out later on when we're working with organic chemistry. So this is obviously not the final molecular formula. This is the empirical formula, and this empirical formula will have to be multiplied up by some whole number to give us the molecular formula. We might multiply it by 2 and get C2H6, or we might multiply it by 3 and get C3H9, or we could get any combination as long as it forms some viable structure. So step 1 is to take the percentage and divide it by the atomic mass. Step 2, once you have found the product, is to divide each of those by the smallest product. Step 3 is then to work out the product and get the ratios, and step 4 is to actually write the empirical formula. Let me do another one for you. This will be a much more complicated one, and this one comes from the ESA textbook, and I will set you some questions to do out of there. But here's a question about vitamin C. And chemists have found out that vitamin C is 40.92% biomass carbon and 4.58% biomass hydrogen and 54.50% biomass oxygen. The first thing that we're going to do is put the elements across the top of the page so that we can work in columns. The next thing that we're going to do is write in the percentage. So we had 40.92% for the carbon, we had 4.58% for the hydrogen, and we had 54.5% for the oxygen. So now we're going to divide by the atomic mass. Carbon's atomic mass is 12. We'll find that from the periodic table, or the data is going to be given to you. Hydrogen's atomic mass is 1, and oxygen's atomic mass is 16. When we work out the product, 40.92 over 12 is 3.41. 4.58 is about 4.58. That's an easy one. And 54.5 over 16 is 3.406. So we're going to take the smallest of these, and you'll notice that these two are about the same. So I'm going to take the smallest one. I'm going to actually round that up to 3.41, and so my smallest number is 3.41, so I'm going to divide by 3.41, and my ratios are 1.34 and 1. You'll notice that this is almost 1 1/3. It's very close. So what we would do now is round up to the nearest half or to the nearest third. And I'm going to say that that's pretty much a third. So I'm going to say that that's 1 1/3. So what I'm going to do is I'm going to multiply by 3 to get whole numbers. So I'm going to end up with 3 to 4 to 3. This means that my empirical formula is going to be 3 carbons to 4 hydrogens to 3 oxygens. So the empirical formula for vitamin C is 3 carbons to 4 hydrogens to 3 oxygens. Now, in the next part, we're told that the molecular mass of vitamin C, we're actually given the number for that, and we can work out the multiplier. And I'm going to stop us there.